This time on KEI Fabrication. Alright folks, what I got going on here is these are the lowering blocks. Hey folks, welcome back to the shop. Hey, I just took advantage of a sunny morning. It's supposed to cloud up and rain the rest of today and the rest of the weekend. So I ran up to the scrapyard, and the reason why I went was to try and get some material to make some lowering blocks out of. So I am going to, this is exactly the right length. I've got to cut it down to the width of the spring, and then I'll put a hole in it for the drive pin. And what I do for the drive pin at the top is I drill and tap for a 3/8 socket head cap screw, and the socket head cap screw is the exact diameter of the spring perch. So that'll be my lowering block. So I got a bunch of other stuff that was in the bin. While it's there, you might as well grab it for stock. And I think I paid for everything you see here less than $20. So not bad. I got some various stocks, a really nice piece, a 1/4 inch plate. So we got some stock to create whatever kind of projects coming down the road. Alright folks, what I got going on here is these are the lowering blocks, or going to be the lowering blocks for the rear end. They're 1 1/4 tall, 4.5 inches by 4 inches. So I'm going to use the bandsaw to rough it out to 2.5 inches wide, because that's the width of the leaf spring. I have the center marked here that I will put the end mill in, so the drive pin can go in here, and so I'll use the Bridgeport to smooth out the side after I rough cut it on the bandsaw, and I'll show you the finished product. So the reason why I'm doing this is I'm waiting for the paint to dry on the rear end, and when I put the rear end in, I want to have these ready so they can be installed. So folks, I cut the 4.5 inch blocks down to 2.5, and you can see it doesn't leave too bad of a finish on here. So what I did was I cut just outside of the line, so when I run the end mill down to take it off, I know I can go down, just remove that line, and I'll be exactly at 2.5 inches. Here, if you ever get a chance to buy a vertical bandsaw that cuts metal, man, I highly recommend it. It's almost as good as a plasma table. I'm able to cut, this is a 2-inch diameter circle out of 1/4 inch plate. So I know I keep trying to talk you guys into getting a metal cutting bandsaw. I use this for both steel and aluminum, and I just cut through 1 1/4 thick aluminum, and it's not even it's still cool to the touch. So nice, efficient. Once, if the blade speed is right and you got the right blade on there, but I use the same blade for steel and aluminum, and I haven't touched this thing in terms of, once I got it up and running, in 25 years. I've probably gone through 50 15 to 20 of these blades just for the amount of material I've cut. Hundreds and hundreds and hundreds of inches worth of linear cuts around in circles and contours and other kinds of shapes. So this thing is probably my most frequently used tool in the shop. I use it to cut wood if I'm doing patterns, or even just trimming something, a block of wood to use to hold something up. It does all that just fine. It even cuts sheet metal pretty well. So because the blade, I buy a special blade that has I believe it's 100 teeth per inch, and it's only 25 thousandths thick, so it's really efficient in terms of removing material, and the blade is good and sharp. You can follow the scribe line and stay right with it, and really not have to modify the parts that you cut much at all in terms of putting them on a belt sander or taking just touching them up to take the saw kerf out of the material. But really a useful tool. The components, this was literally in the front yard of somebody's house for sale with just a handwritten sign on it 25 years ago when I was driving home. This was a meat saw. The blade speed was super fast. A friend of mine bought a whole pallet of stuff at an auction, and this gearbox is a 16-to-1 gearbox. In that pallet was Lovejoy couplings, and I just threw a small half-horse motor on it, and I have never touched it. I whipped up this quick bracket to hold everything. I built a platform to put it on wheels, on casters, and it's got a brake on the front of it to stop it from moving around when you're cutting. And I have literally, other than putting new blades on it every once in a while, which they last about 3 to 6 months depending on how much material you cut, I haven't touched it. The blade guide I made myself out of, these are rollerblade wheel bearings, and just to get the blade guide, and this is just another simple roller bearing, so when you put pressure on the blade, it's rolling against this roller. You're not pushing the blade off of the drive shifts. And there is guides down below, as well as another bearing down here to counteract the force of you pushing on the material and trying to move the blade inward. So this keeps this blade centered on the drive pulleys, and this, when you're cutting curves and contours, these guides help keep the blade straight, so your cut comes out as desired. So that's enough rambling about the bandsaw. So about my welder, I told you I'd talk about my shop equipment here and there. This is an old 1970s Chematron welder. This came out of an industrial weld place. The maintenance department took it out and replaced it with some new ones. It had a bad circuit board. I took the circuit board out, had it sent out and rebuilt, and I ended up with this massive welder. It's huge, but it's a 300 amp welder. Does both steel and aluminum. It actually will do stick. It'll do water cooled. I just have an air cooled torch because I'm doing relatively thin wall tubing. And for $169 I ended up with this welder. This was ready to be scrapped from the company that had it. So again, as I said in my first video, a lot of this equipment came my way in that exact fashion. And so I put a little bit of money into it, and it's been a great welder for 25 years. It's been in my shop, and it was an industrial welder for at least 25 years before that. So next time on KEI Fabrication.